this nature is completely made up of two things, matter and lots of energies or forces. Okay, so you will study about this matter and these energies. Clear? So when you study about forces, energies and matter, you will have to measure so many things. Okay, say any matter or any energy force you take. So any energy you take. And how will you measure? How will you describe them? You can describe them with the help of physical quantities. Okay, so you can describe any energy or force or matter with the help of certain quantities called physical quantities. So initially I am starting with physical quantities. Okay, so in this video I will deal with various physical quantities, their units, and later I will give an idea about dimensions. Okay, say, and in my next video I will come up with dimensional analysis. So more things about dimensional formula, etc. we will discuss. And other part of a chapter is all about errors. Okay, so when you do certain measurements, we will end up with so many errors. So we will study what type of errors are there and how to deal with the calculations relating to those errors. Okay, so this is all about the chapter actually. So first thing we'll study about the physical quantities and their units. And later we should have an idea about dimensions, dimensional formula, dimensional analysis, and later errors and their calculations. Okay, so here I am mainly dealing with physical quantities and their units. Okay, so can you all tell me what you mean by physical quantities? See, these are some measurable quantities. Okay, I can say they are measurable quantities that describes, that helps to describe, matter or energies. Okay, so what is the use of these physical quantities? Help in describing matter or energies. Okay, clear? Because physics is all about study of matter and energies. And if you want to describe a matter or energy, we want the help of certain quantities that can be measured. So those measurable quantities are called as physical quantities. Okay, actually there are three types of physical quantities. So we have three types of physical quantities. Okay, so what are they? They are fundamental physical quantity, first one. Under that, the first type is fundamental physical quantity. Okay, I'll just write it as PQ. Second one, derived physical quantity. Derived physical quantity. And the third type is supplementary physical quantities. Supplementary, or I can also say that additional physical quantities. Okay, so these are the three types of physical quantity. So let us discuss one by one with their units. So I will go with the fundamental physical quantities. So what do you mean by fundamental physical quantities? They are the basic physical quantities. Say for example, I want to describe about this particular chalk piece or chalk pencil. How can I describe? I can talk about this chalk pencil with the help of a physical quantity called length, isn't it? With the help of physical quantity called length, right? So we say, when I measure this length, I would say it is 10 centimeter. I can say it as 10 centimeter or 15 centimeter, right? So any physical quantity will involve some number with some unit. Okay, so this is, try to understand, any physical quantity can be expressed with some number, and number is always associated with some unit. Okay, say For example, if you don't mention any unit, there is no value for this physical quantity. Imagine, okay, length of the chalk piece is just 10. When I write the length of chalk piece is just 10, what is the meaning? What meaning you have? Okay, say for example, I'll go to a shop and I'll ask, give me 50 rice. When I ask them, give me 50 rice, he would wonder, what is this 50 rice? 50 kgs or grams, or what exactly you mean? That's what he will ask, right? So you have to clearly mention 50 is a digit, yes, but 50 must be associated with some unit, no? Only then you will have a clarity. So when you exactly say, I want 50 kgs of rice, then that shopkeeper will understand. Or you must say, I just want 50 grams of rice, then the shopkeeper would understand. But if you just say just 50, there is no meaning for this digit. There is no meaning for this digit, right? So meaning will come when you add a unit for a number. Right? So any physical quantity, it may be a fundamental physical quantity, derived physical quantity, or supplementary physical quantity, it should be there in this format. Okay, it will always have some number, some digit, and that is associated with unit. Clear? So how do I define unit here? You all know the importance of unit now. Without unit, there is no value for the number. Okay, so now how do you define unit? What is the importance of unit here? See, unit means, it is something that tells about how big, right? Or how small is the quantity is. How big or how small is the quantities is, right? And for a physical quantity, you can have two or more types of units. Okay, say for example, there is a fundamental physical quantity length. Okay, say for length, the unit length is always measured in the unit meter. Okay, so we write it as small m. Not only meter, you can also describe length in terms of centimeter, right? Say one physical quantity can have many types of units. Clear? Say for example, say length of some rod is about, I would say, it is 100 centimeter. Okay, or the same thing I can also call it as 1 meter, right? Say here centimeter is also unit for length, meter is also unit for length, or I can also talk length in terms of foot, I can also talk length in terms of inches, right? Say units are many for a particular physical quantity. There is only one physical quantity, length, but it can be expressed in many units. So unit is the one which is giving an idea about how big the quantity is or how small the quantity or measurement is. Okay, say that way unit is helpful. So any physical quantity must definitely be associated with the unit. This is what is telling you the quantity of a particular matter or the force. Okay, fine. So but meter is a standard unit. So we have different types of units, different systems of unit. So in that, SI unit is the most standard unit which is followed everywhere. Okay, so for length, the standard unit is meter. Like that, the next physical quantity, all these are fundamental, very, very basic physical quantities I'm telling you, right? So next is mass. Mass is another fundamental physical quantity where the unit, okay, so all these are units. Here the unit is kilogram. Okay, in short we can mention as kg. So the third one is time. So times unit is second, smallest we can write. So the fourth one is temperature. Okay, we can call it as thermodynamic temperature or just temperature, and here the standard unit is Kelvin or K. Okay, and then fifth one is electric current. Electric current is another fundamental physical quantity, and the unit of electric current is ampere. We all know this. Okay, so these units are called fundamental units. What do you mean by fundamental units? They are the units of fundamental physical quantities. That's it. And now you have the sixth one, amount of substance. Amount of substance. For this, the unit is mole. Okay, and the last one, seventh one, is luminous intensity. Luminous intensity. For this, the unit is candela. Candela. Okay, so these are the fundamental physical quantities and fundamental units, right? So from these fundamental physical quantities, there are many other quantities which are derived. Okay, so we can derive many other measurable properties from these basic properties. So let us go for derived physical quantities and their units. See guys, observe few of the derived physical quantities and their units that you frequently use it in physics. Okay, so the first one is area, right? So what is area? Area we generally call it as length into breadth, right? So what is the unit for length? It is meter, right? And what is the unit for breadth? Breadth is also, it's talking about some length, right? Some distance only. So here also the unit is meter. So what is the unit for area? It is meter square. Meter square, or just I can say m square. So here m is a letter that can indicate meter, right? So the unit of area is meter square. So area is the quantity, physical quantity, which is derived from which basic physical quantity? It is derived from length only. Okay, so there are only 7 basic quantities. From them, every other physical quantity can be derived. That's why they are called as derived quantities. So the next important derived physical quantity, I can go for volume. Okay, so what is volume? Volume is length into breadth into height. Right, so all are like distances. On length is a distance, breadth is a distance, height is a distance. Say for all the three, the unit is meter only. Meter, meter, meter. So what is the unit for volume? It is meter cube, right? Meter cube. Fine. And later, let me go for velocity. Say velocity. So what is the formula for velocity? Velocity is nothing but, you know, some displacement, right? It's a displacement, or let me call it as distance. Some distance traveled by a particle from point A to point B, right? So distance divided by time, right? So again, distance is like what? It's a length that you measure, distance, right? So the unit is meter, meter, and time. Time unit is what? Second, right? So what is the unit for velocity? It is meter per second. This is what we will write. Fine. Say if you have to write the unit for a particular derived physical quantity, you must know its formula. So knowing a formula is very important for derived case. Fine. And next one I will go is acceleration. Acceleration. Okay, so what is acceleration? Acceleration A is nothing but velocity by time, right? Velocity by time. Okay, so velocity unit you know, meter per second. Time is what? Time is also second, right? So this thing I can write it as meter second square, inverse square, right? Meter per second square, or I can also write it as meter per second square. So anything is fine, right? So this is the unit for acceleration. And now let me go for force. So what is force here? Force is nothing but mass into acceleration, right? So mass is what? What is the unit for mass? It is kg. Acceleration unit, just now you studied, it is meter second square, right? So if you join what is the unit for force you will get? It is kg meter per second square, or like this. Okay, so this is the unit for force. Clear? And now let me go for discussing about the next one. The next one is energy or work or energy. And usually in case of force, this unit is also generally called with the term Newton. Okay, so Newton. So Newton or kg meter per second square is one and the same. So instead of writing kg meter per second square, you can commonly write it as Newton. Okay, so now let us go for work and energy. So what actually we mean by work and energy? It's nothing but force into distance, right? So force unit we know. What is the unit for force? Kg meter per second square, right? Into distance. Distance is again, it's like a length. You will measure it in meter. So what do you get? Kg, meter into meter, meter square, and per second square, right? So this is the unit for energy or work. So this thing can be called it as joule. Clear? See, the way you called the whole thing as Newton, and here the whole thing you can call it as joule. So the common unit for energy or work is joule. So what actually we mean by joule? It is kg meter square per second square. And there are many numerous derived quantities are there, and 3 more examples, and its units you are going to write and post it in a comment. Say power. So what do you mean by power? Actually, power is nothing but work by time. Okay, so what is momentum? Momentum is mass into velocity. Okay, and pressure is nothing but force by area. Right? Say, I gave you the formulas, and you can try writing their units. Okay, so don't forget to mention the units of power, momentum, and pressure in the comments. Right? So this is all about derived physical quantities. And now we will go for the supplementary physical quantities. See guys, there are mainly 2 supplementary physical quantities. One is plane angle. We call it as plane angle or just angle. Okay. The other one is solid angle. Solid angle. So what do you mean by plane angle? See, exactly when 2 lines, say this is one line and this is another line, right? And at this point they join, and this is what we call angle. Okay, let me call this angle with the letter theta. And this theta is a very small angle actually, so we can also call it as d theta. D means what? If anything is very small measurable quantity, then it is represented with d. It is one of the mathematical operation actually. Okay, and now how do you calculate this theta? This can be calculated just by knowing the value of arc, that is the length of arc and the radius. Say if you consider this as a big sphere, then and this one will be a radius, right? So this length is nothing but radius. So this is radius r. If you think that this is a big sphere, it's a radius r, and this is arc. Right? So how do you calculate this angle here? This is what we mean by plane angle. Okay. So d theta can be calculated by knowing arc length. It is the ratio of arc length divided by radius. Okay. So this is what we call plane angle, and this is how it can be calculated. So how do you define this plane angle? So I'm just writing its definition. It's nothing but it is the ratio of arc length and radius. Say for board point of view, if you have to know what is plane angle's definition, then it's nothing but ratio of arc length and radius. Okay, so and the unit of this plane angle, it has a unit, and unit is called radian. Unit is called radian, or in short we will just write it as RAD. Okay, so usually any angle we represent in degrees. So degree is one more unit that we have studied so far right from our lower classes. Along with the degree, we have one more unit for angle, that is radian. Okay, and there is a relationship between degree and radian. Okay, so the relationship is 360 degrees is equal to 2 pi radian. 2 pi radian. Okay, so this is the relationship. Or you can also remember this way, 180 degrees is equal to pi radian. Pi radian. Okay, so anyway, anything you can remember, right? So 180 degrees is equal to pi radian. You know, this is the relationship between degrees and radian. Okay, so both are units for angle. Which angle? Plane angle. Okay, so you can give the units in degrees and you can also give the units in radian. The relationship, if you have to convert from one unit to another one, you must know the relationships, right? So this is what the relationship between degrees and radian. And from this, can you calculate 1 radian? 1 radian is equal to how many degrees? How many degrees? Just what you have to do? We know 180 degree is equal to pi number of radians. So 1 radian is equal to how many degrees? So it is just, it's like 180 divided by pi you will do, right? So 180 divided by pi is equal to how much? It will be approximately 52.9, or you can just write 53 degrees. Okay, so 1 radian is equal to these many degrees. Clear? So this is, say this radian to degree conversion is quite, you know, it's important. Okay, in certain concepts. So you must know what is the relationship between degrees and radians. So that's all about your plane angle. Now let us go for discussing solid angle. See here, imagine you have a sphere. Imagine you have a sphere. Okay, so let me just cut this part. Okay, this part. Okay, this is the part, and this is the center, right? And I will extend this here, right? And it becomes a cone. Right? And you know what? This angle, you see, this is the angle in 3 dimension, right? This is the angle in 3 dimension. Let me call this as d omega. This angle can be called it as d omega. Okay. Say here, this angle, this 3-dimensional angle in a cone shape is what we call solid angle. Okay. Say, how do you calculate this solid angle? Okay. It is nothing but it is the ratio of area of arc divided by, this is radius and this is radius, right? So radius square. Okay, so this is how you will calculate solid angle, right? And even this solid angle has a unit, and its unit is called steradian. Okay, so what is solid angle? It is nothing but the ratio of area of arc. If you want to calculate this angle, okay, you will take this area of a arc, and this is also a very small value. Okay, so area of a arc divided by radius square. When you do, you will get solid angles value, right? So plane angle and solid angle. So both are the supplementary physical quantities. So what is the unit of plane angle? Radian. How do you calculate plane angle? This formula. What is the unit of solid angle? Steradian. How do you calculate solid angle? It is just the area of the arc, that small arc divided by radius square. Okay, so that's all about the supplementary physical quantities. So now let us go for discussing dimension and dimensional formula. Let's try to understand what is the difference between unit and dimension. Okay, say in today's class I'll give a basic idea about a dimensional formula. In my next class I will discuss about dimensional analysis, which is the most important topic of this chapter. Clear? See guys, dimensional formula is some sort of formula which is used for derived physical quantities. Okay, we all know derived physical quantities are extracted, they are made up of fundamental physical quantities only. So this dimensional formula will give an idea about like which fundamental physical quantities are involved in making derived quantity. So you may be confused with the sentences that I told you now, but it's very simple. First, let me write this sentence. Say when I give you one example, you will understand. Say dimensional formula is nothing but it's a way of expressing derived physical quantities. We all know derived in the sense all that area, volume, density, all are derived. They are made up of from fundamental physical quantities only. So way of expressing derived physical quantities in the dimensions of fundamental physical quantities. Okay, so what do you mean by expressing derived physical quantity in the dimensions of fundamental physical quantity? Say it's a way of telling that if you have a particular derived physical quantity, you are telling with which fundamental quantities it is made up of. Okay, so this is definitely involves few fundamental physical quantities, right? See, looking at the dimensional formula, you will understand that which fundamental physical quantities combine together to give a particular derived physical quantity. Okay, say for example, we know the fundamental physical quantities: length, right? Mass, time. Okay, let me take initially these three fundamental physical quantities, and what is the dimension of length? Length dimension is like this. So instead of writing length L-E-N-G-T-H, we can just write like this. Say L bracket. Bracket means what? It means that dimension. Okay, nothing but just a fundamental physical quantity. It is just a fundamental physical. Bracket implies it's a fundamental physical quantity. L means what? Length. Okay, say and this is dimension. Okay, this if I write something like this, it means that I'm writing dimension. Okay, so this is physical quantity, fundamental physical quantity, and this is fundamental dimension. Okay, and mass, I write mass something like this. Time, I'll write time as capital T. Okay, say any physical quantity which you will express in this way, in these three fundamental physical quantity, then it is called as dimensional formula. So let us see one example. Say this idea you must have. Length means you will write L, mass in the sense you will write like this, time in the sense you will write like this. Fundamental physical quantities, their dimensions. So now, for example, you have, let me take it as velocity. Velocity. So what is velocity? I'm writing dimensional formula for velocity now. Okay, so dimensional formula is mainly applicable for the derived units. It is telling you what fundamental quantities are there in the particular derived quantity. Okay, say velocity. You must know the formula of velocity initially. Okay, so without knowing a formula, writing dimensional formula is impossible. So definitely formula is important. Velocity means what? It is distance by time. Okay, so distance in the sense what? Length, right? So you will write L. What is the dimension for length? Distance means length. Dimension for length is L, and dimension for time is T, right? So the dimension of velocity, dimensions of velocity is L, okay, T, and you will also express in terms of m, but there is no mass term involved in the velocity, so you will write it as 0. Okay, so m to the power 0, L power 1, t power 1. That means one length is involved, one time dimension is involved, and 0 mass dimension is involved. That's what it means. Or you can simply, the whole things you can put it in one single bracket, like m to the power 0, L1, T1. Okay, so this is the dimensional formula. This is the dimensional formula for velocity. So hope you have observed and got the idea how to write a dimensional formula. So writing dimensional formula is very important. So looking at the dimensional formula for velocity, what is the information you got to know? Yes, looking at this, we can say that there is no fundamental quantity called mass involved here. There is one length and there is one time. Okay, sorry, here inverse. Okay, let me, this is time in the denominator, right? Say time inverse. So time inverse, right? So this is the dimensional formula and this is how we will write. Okay, so now let us try to write for other derived physical quantity. Okay, so next let me write it for acceleration. So what is the dimensional formula for acceleration? Right? What is acceleration? You must know the formula. It's not that you have to mug up and keep it in your mind. No. If you know the formula, your work is over. Acceleration is what? It is nothing but velocity by time, right? Velocity by time. And already you know what do you mean by velocity. So what is velocity here? Velocity is dimensional formula, you know. What is that? You have m to the power 0, L to the power 1, t inverse, right? So this is a dimensional formula for velocity. You already know it. And divided by time. Okay. So this time when you write in the numerator, how would you write? So what is the final dimensional formula for acceleration here? You will write this as m to the power 0, L to the power 1, t minus 2. T minus 2, right? So this is the dimensional formula for acceleration. Okay, so this is how, nothing to by heart here. Just if you can remember the formula, then everything is just expressing them in the dimensions of length, mass and time. Okay, so I can simply tell dimensional formula is nothing but expressing a derived physical quantities in terms of length, mass and time mainly. Okay, other fundamental quantities also you will use, but mainly majority of the derived formulas you can express in these three terms. Clear? So let us go for a few more examples here. And let me take, you can take force. So what is the dimensional formula for force? So what is force here? Mass into acceleration. Mass into acceleration, right? So acceleration's dimensional formula just now you have derived. What is that? m0 L1, okay, t minus 2, right? And mass, say mass means what? It is m, right? What is the dimension for mass? It is m. So join, you can write it as m to the power 1, L to the power 1, t to the power minus 2. So this will be a dimensional formula for force. So I think now you got an idea how to write the dimensional formula. Now let us write the dimensional formula for few more physical quantities which are the most important. See guys, can you all try to write dimensional formula for gravitational constant? Okay, so gravitational constant. Hope you have an idea about gravitational constant, that is G, right, which you might have studied in your lower classes. Okay, so anyway, even if you don't have an idea, just just follow the thing that I'm showing on a board. See, writing dimensional formula for gravitational constant. And you know what? Gravitational force, F. Let me take it as F. What is this F? This is nothing but gravitational force. Knowing formula is very important. Okay, so gravitational force is equal to G into m1 into m2 divided by r square. So this is the formula for gravitational force. And I'm going to write dimensional formula for this G. So just rearrange what is G. G is equal to F into r square divided by m1 into m2. See here, m1 and m2 are masses. Okay, fine. So now, okay, major thing is over. I got a formula now. Now I just have to put the dimensions, right? So G is equal to force. Force is again what? Mass, right? Mass into acceleration. Acceleration into r square divided by m1 into m2. So one mass in the denominator gets cancelled, right? So what is the dimension of acceleration? Just we have studied. Okay, in case even if you don't know the dimensions of acceleration, what is acceleration? It is velocity by time. Okay, so velocity dimension is what? Again, velocity is what? Velocity is distance by time. So its dimension is it's like m to the power 0 L1 t inverse, right? So acceleration's dimension is m to the power 0 L to the power 1 t minus 2, right? Say that's what you will write here, right? Acceleration dimension, just now we have derived there, m0 L1 t minus 2, okay, into r square. R is what? It's like a radius. Again, it's like length only, right? So L square, I can put it as L square, divided by mass. Mass is nothing but m, right? One mass is there. Here one mass and one mass got cancelled. So only one mass, m2, is there, that is m. So now just if you what it is, here m to the power 0, that means m factor is not there only. Okay, when it is not there, just take it, not there. M to the power 0 is 1. So it is m minus 1 L 1 and 2, right? 1 plus 2, it is 3. M minus 1 L3 and T minus 2, right? So this will be the dimensional formula for G. Okay, so just, it's not that you have to remember everything. Say we know G is equal to, this is the main formula. Again, force we know, it's mass into acceleration. So one mass got cancelled. So acceleration is what? It's velocity by time. So if you don't know its dimensional formula, again go on deriving it, then substitute. So R is what? Radius, that means length, right? So L square divided by M. So you can write this as M inverse L 1 plus 2, 3 and T minus 2. So this is how you can write the dimensional formula for any derived physical quantity. So now let us try for these questions. Write dimensional formula for pressure and power. Okay, so this is the homework. I also gave you to write their units, right? I gave you the formulas. See, once you know the formula, you can write the dimensional formula also. Write both units and dimensional formulas for these two physical quantities, right? So I think with this you got an idea about units and dimensions, right? So we got a basic idea about units, what are the different units you have for different physical quantities, and then what do you mean by dimensional formula and how you can write the dimensional formula. Everything we studied, right? Okay, so now one more question you have, that is, can you write the dimension for angle? Is there a dimension for angle? We studied plane angle. So can you all write the dimensions of plane angle? What is the formula for plane angle? It is arc length divided by radius, right? So arc length is what? L, length means L, divided by radius is also like length only. So cancel. Angle is dimensionless. Some of the physical quantities like angle may not have a dimension. Okay, so angle has no dimension. It has a unit. Angle has a unit. What is that unit? Radian. But it do not have a dimension, right? It's like that. See, for a particular physical quantity, you can have more units, right? But dimension can be only one. Dimension can be only one. Remember, this is very important for a particular physical quantity. Okay, say for example, you have a length. Okay, length can be written in many units. Say I can write it as like 1 meter, or I can also write this as 100 centimeter, right? Say meter is also talking about length, centimeter is also talking about length only, but units are different. But what is the dimension? Here the length dimension is L, and here in this measurement also the dimension is L only. So dimension can be same for a physical quantity, but units can be different, and units can always be converted from one form to another form, right? So these are the fundamental aspects about units and dimensional formula. So in next class I will come up more aspects of this dimensional formula. So what is the main use of this dimensional formula? One thing is, looking at the dimensional formula, you can know something about a physical quantity, like with which fundamental quantity it is made up of. That idea you will get. Along with that, we have lots of uses with this dimensional formula that we will try to understand in the concept called dimensional analysis. So that is our next topic. Thank you so much. Do subscribe our channel to learn the concepts in a easiest way and in a detailed way. See you all.